So the last part of your chemical analysis booklet, it goes on to a wee section about testing chemicals, which is obviously quite a useful thing to be able to do when you're analysing something. If you don't know what's in it, there's kind of like a collection of tests that chemists can use to give them an idea of what that substance might be if they don't know it. Now, there's hundreds and hundreds of these tests. It's a whole big area of chemistry. Obviously in double O chemistry, you're not going to look at too many. When you get to A level, if you pick chemistry, you look at a few more. So we're just kind of scratching the surface, but there are a couple of tests you're meant to know about for how you might identify unknown substances. The first substance you might identify is water. Maybe it sounds like quite a silly one to test for because water is obviously all around us. But if I give you a colourless liquid, that could be a few different chemicals. It could be ethanol, it could be an ester, it could be something else, it could be a hydrocarbon. You might not necessarily know it's definitely water. So we have to rely on a test to work out if something is water. The test we use again, it's not that difficult to recall, but maybe seems a wee bit strange to look at. The chemical we use to test if something is water is a chemical called anhydrous copper 2 sulfate. Now, copper sulfate is something you've encountered before in the acids, bases, salts topic, because we learned that copper sulfate, when you make it as a salt in a reaction, generally gives you a blue colour. Copper sulfate is famous for being blue. However, it's only blue when it's in water or has water attached to it, known as the hydrated form of it. Hydrated copper sulfate actually has this slightly strange looking formula. That's your copper sulfate part, that should be familiar enough, CuSO4. It's got a dot after it and it's called 5H2O. So we're introducing a kind of concept known as water of crystallization. It sounds a bit confusing. All it is the fact that most ionic substances, quite a few of them, quite like to have water attached to them to make them a bit more stable. So if they've got water attached to them, water of crystallization has this definition: water chemically bonded into a crystal structure. They're a lot more happy. Copper sulfate is one of these chemicals. It doesn't like being by itself, use copper sulfate. It quite likes having some water along for the journey with it. The key thing about copper sulfate is whenever it's got those 5 waters attached after that wee dot, it's a blue colour. Copper sulfate's only blue when it's got 5 H2Os attached to it. If you had copper sulfate just by itself, it is actually naturally a white colour. So when you add some water to it, it turns blue. You're probably putting two and two together here. This would be a useful test to check if something is water or not, because water is the only thing that will turn anhydrous, just to clarify, anhydrous means does not contain water of crystallization, hydrated means it does. If we take anhydrous copper sulfate, which is naturally a white colour, and if we test this unknown substance, which might be water, by adding it to this copper sulfate, if it is in fact water, the copper sulfate will turn blue because it'll turn into the hydrated form, which has water of crystallization. So that's all quite new stuff, but there's not too much detail to it. You need to know the test for water is to use anhydrous copper 2 sulfate. The result you get, it turns from white to blue. It's turning blue because it's now hydrated. It contains water of crystallization, which is water that just attaches itself to a substance. And it's turning from anhydrous to hydrated. So that's a test for one specific substance. The second type of test we look at, called flame tests, test for quite a range of different substances. So we'll look at the actual method and the results in a second, but in terms of what you might use a flame test for, here's the kind of scenario. I might have in front of me a white powder. I have no idea what that white powder is, but something I can possibly guess is the type of bonding in that white powder, because I know from my bonding topic some properties of different bonding structures. If this is a white solid, it's got quite a high boiling point, more than likely it's going to have ionic bonding. So if you go along with that for a second, ionic bonding generally involves a metal joining to a non-metal. So that gives me, let's write that down, metal and non-metal. When they form an ionic compound, you hopefully remember that they have different names for the different ions. The metal forms the positive ion, it's called the cation. And the non-metal forms the negative ion, called the anion. Now, that seems a bit of a strange tangent going on here. The reason I'm talking about bonding and cations and anions is what a flame test is for. It allows you to identify cations or metal ions in a compound. So it doesn't allow you to identify the whole compound. I need a separate test for anions. Again, I found out the fact you learn about those in A level. But I can work out some of this compound. I could work out if it contains sodium or potassium or lithium or calcium, for example. And that gives me halfway to working out what the substance might be. The way I do the test is I use a flame test. So that involves using a Bunsen burner and using a some of the sample. How this works is as follows. The basic principle is I can tell what a substance is or what a cation is by looking at the colour of it when I put it in the flame. Different metals have different characteristic colours when they go into a flame. Now, how they get into the flame is kind of not as easy as it sounds. I can't use a spatula because spatulas have their own flame colours because they're made of chemicals. I use a special piece of apparatus called a nichrome wire. Nichrome is an alloy of nickel and chromium. And why I use it to put my substance into the flame is that nichrome is a special property. It doesn't give off its own flame colour. So it's safe to use to actually be able to see what the colour of the actual flame I'm looking for is. It doesn't spoil the result by giving its own flame colour. It's not as simple again as just sticking my wire into my compound and sticking the flame. I need to make sure it's clean. So in your official method, which your exam board says you have to know, it talks about this cleaning of this wire first before you use it for your test. So what I do is this. Take a piece of nichrome wire with a lip at one end. You have to know it's called a nichrome wire. That's a specific bit of terminology. The way we clean it is like this. We dip the loop of that wire into concentrated hydrochloric acid and place that dipped piece of wire into a hot blue flame of the Bunsen burner. So the combination of heat and strong acid actually is a good way of cleaning your nichrome wire. You would do that a few times until you no longer see any impurities or any colourfulness to your flame. Remember, nichrome wire, when it's clean, should be nice and colourless. Once you got clean, you need to get your powder to stick to your wire. So how you generally do that is you dip your nichrome wire one more time in concentrated hydrochloric acid. This time it's just being used to make your wire pretty much wet, so the solid will stick to it. And put that wire onto the solid ionic compound, which is sitting in a watch glass. Hold the lip with the solid compound in the hottest part of the flame, so you need a roaring flame, not a safety flame, and record the characteristic colours, and then do it for different types of chemical. So one thing you need to know in the exam, they could ask you for a wee 3-mark question to describe that method about how you clean it with concentrated hydrochloric acid, put it in the hot part of the flame, put it into acid again in your compound, and then put it in your flame, see your colour. And they could also ask you to recall the colours of some ions. Now, there's lots of ones you can learn about. They only give you 5 to know off by heart, so I'm just going to give you the results in this wee table. So these are the colours you're meant to know about, so you can copy them across into your table. You're meant to know lithium, sodium, potassium, calcium, copper. They're all metals. But just being careful, remember we're not looking at individual metals like the elements. These are these elements within compounds. So we're talking about the lithium cation, the sodium cation, potassium cation, calcium and copper cations. Lithium's got a crimson colour. It's kind of like a pinky striking red colour. Sodium is yellow or orange. Now the reason it's yellow or orange is it depends on the person, what they actually see. The important thing is for the exam, you're only meant to put on one of those options. So if you think it looks yellow, write yellow. If you think it looks orange, write orange. Potassium's lilac, we looked at that before. Calcium gives a brick red colour, it's kind of like an orangey red, the colour of a brick. Think about the colour of the front of the school. And copper finally is blue-green. Now this is a wee bit different, it's got a dash there. That means you're meant to put both blue and green, because what you find with a copper flame is actually do see shades of both. It looks a wee bit blue and a wee bit green as well. So you put both down. So obviously it's a wee bit artificial me just writing those down. You're not actually seeing those with your own eyes. What I'll try and put in the Google Classroom is a wee video showing the experiment being done, which will give you more of an idea what it looks like in real life, which you probably will be able to do when we get back into school.